So in this lesson, we're going to talk about exponents. What are exponents? How do we use them if we encounter them in a problem? Alright, so before we do anything else, let me show you what an exponent looks like. So let's look at a very simple exponent. Let's say we have the exponent x, the exponential form x to the second power. So here's going to be our example. When we talk about exponents, there are two distinct parts that we have to mention. The first part is the exponent itself. So the exponent is typically a number. In our case, we're only going to deal with integers. So it could be a positive or negative whole number. Whole number, I guess. No fractions or decimals for us yet. Those do exist. We're not going to deal with them. So for us, the exponent is going to be an integer. So positive or negative numbers, no fractions or decimals. They're always located in this upper right corner, right up here. And they modify the base. So the bigger number or variable, because it could be a number or a variable, or any kind of a number, so rational numbers work here too, fractions, decimals. This is called the base. So together they form what is known as the exponential form. So the exponential form is both the base and the exponent together. Together they form the exponential form of any number. That's what it would look like. Now, what does this mean? What does an exponent actually do? I just told you it modifies the base. How does it modify it? So let me write down, I'm going to lift this up a little bit, and I'm going to write down our example right here. Make sure I'm not cutting you off. Nope, we're good. So in an exponential form, the exponent, the little number right up here, tells you how many times you should multiply the base against itself. So the exponent will tell you how many times should you multiply the base against itself. And this is what it looks like. My exponent here is 2. That means I should take my base, which is x, and I should multiply it against itself twice. Just like this. And that's all it means. The exponent tells me and you how many times should you multiply the base against itself. In this case, then the exponent was 2, which means we multiply the base, and the base was x, against itself twice, x times x, and you're done. This is exponential form. This is not exponential form. Any questions? It really is that easy. So let's take a look at some examples, and let's see if we can make this a fairly short lesson. So let's say we have a pretty simple example here. 3 to the second power. Okay, can someone tell me what is the exponent here? If you said 2, you're absolutely correct. And yes, that's a 2, not a z. Don't make fun of my 2's. And can someone tell me what is the base here? And yes, I'm color coding them, so that should be pretty obvious. If you said 3, you're also correct. So my exponent is 2, my base is 3. Can someone tell me what does the exponent do? What does it tell me to do? How does it modify the base? If you said that the exponent tells me how many times I should multiply the base against itself, you're absolutely correct. And here I have 2 for the exponent, which means I should multiply my base, which is 3, against itself twice, just like this. And can someone tell me what is 3 times 3? 9. Exponential form? Not exponential form. So 3 to the second power, or as it is commonly known, 3 squared, is the exponential form of a 9. And really, that's about it. Let's take a look at a few more examples. Let's say I have, let's reverse this. Let's say I have 2 to the third power. What's the exponent here? If you said 3, you're correct. What's the base? If you said 2, you're equally correct. What does the exponent tell me to do here? If you said take the base, which is 2, and multiply it against itself 3 times, you would also be correct. So I have to take the base, the 2, and multiply it against itself 3 times. That's 2 of them, and here it is for the third time. And can someone tell me what's 2 times 2 times 2? If you said 8, you'd be absolutely correct. Not exponential form, exponential form. So 2 to the third power is the exponential form of an 8. Let's do another example, or just to solidify this. Okay, let's take a look at, something a bit more complex. Let's say 3 to the fourth power. Why not? What's the exponent here? If you said 4, you would be absolutely correct. What's the base? If you said 3, you're equally correct. What is the exponent telling me to do here? What does the exponential form mean in this particular case? If you said take the base, which is 3, multiply it against itself 4 times, you would be correct. So I'm going to take 3 and I'll multiply it against itself 4 times. 1, 2, 3, 4. And does someone know what is 3 times 3 times 3 times 3? If you said 81, you're absolutely correct. That's not so bad, right? That's actually fairly easy. And that is, the section 4.1 is mostly this. Now I'm going to do 2 more examples. These are a little bit different, but keep this in mind and you should be just fine. Alright, so the first thing I want to look at is right here. What if I have 1/2 to the second power, or as it's commonly known, 1/2 squared? What's the exponent here? If you said 2, you were correct. What's the base here? If you said 1/2, you are correct. So what does this mean? What does 1/2 to the second power really mean? If you said take a half and multiply it against itself twice, you'd be correct. 1/2 times 1/2. And can someone tell me what's half times half? If you said 1 over 4, you would be correct. 1 times 1 is 1, 2 times 2 is 4. And again, that shouldn't be so bad. And let's take a look at something else. Okay, so that was a fraction. That wasn't bad at all. What if I gave you this? What if I said, lift this up a little bit. What if I gave you 4 times 4 times 4, and I instead told you to put this into exponential form? What would you do then? What would you do then? First question, what is my base? Well, that should be fairly easy to figure out. So what is the base? If you said 4, you would be correct. Now, how many times am I multiplying the base against itself? 1, 2, 3. That's the exponent, essentially. The exponent tells you how many times to multiply the base against itself. Since I'm multiplying the base 4 against itself 3 times, that's the exponent. The exponent is 3. So if I were to give you something like this and ask you to put it into its exponential form, well, that's how you would do it. So 4 times 4 times 4 is 4 to the 3rd power. Again, well, that's not so bad. Let's take a look at another example like that. Let's say I have -2 times -2 times negative, erase this down, -2 times -2. And I asked you to put that into exponential form, because I can do that. What is the base here? If you said -2, you'll be absolutely correct. If I asked you what the exponent is, what would you tell me? What is the exponent here? Now remember, the exponent simply tells you how many times you multiply the base against itself. Base is -2. I have all -2s, and I'm multiplying 1, 2, 3, 4 of them against each other. So if you said 4, you're absolutely correct. And this would look like an exponential form as such. -2, all taken to the 4th power. Now the parentheses are there for a very, very specific reason. It's very important that they remain there. Let me show you what happens if those parentheses are not there. So let me write this out real quick. So -2 to the 4th power example that we just looked at. And then for comparison, let me put down -2 without the parentheses. Now here we figure that the base is -2. That's fairly easy to tell, and we know the exponents for. Now think about this. What is the base right here? And hint, it's not -2. If you said that the base is just a plain old 2, you would be correct. The exponent modifies exactly what it's attached to. The negative now is no longer attached to the exponent, which means the exponent will not modify it. The exponent will consider just the 2 as the base. While the negative was in the parentheses, the exponent observed that parenthesis and it modified the negative number as well. Now that the negative is outside the parenthesis, the exponent will only modify what it's attached to, in this case, the 2. So the exponent is still 4, that never changed. And this is what this number would look like if I were to write it out in its non-exponential form. I have to write the negative out once. It doesn't go anywhere. But that's about it. And then it's the base, the 2, being multiplied against itself 4 times. Now these are very different. These are very, very different because negative 2 times negative 2, that's negative times negative, that's a positive 4. Positive 4 times negative 2, well, that's a negative 8. Negative 8 times negative 2, well, that is a positive 16. In this case, negative 2 times 2, that's negative 4. Negative 4 times a positive 2, that's negative 8. Negative 8 times positive 2 is a negative 16. And since we've been working on the number lines, you can tell these two may look alike, but they're nothing alike. They're on separate sides of the number line, and their values are very, very different. So be very, very careful. The exponent will only modify what it's attached to. It will observe parentheses. If the parentheses is there, the exponent will modify whatever is inside that parenthesis as a whole. But if the parenthesis is not there, the exponent only modifies the base that it's directly attached to. So that is a very, very, very striking point here with the exponents. A very easy mistake to make. Now let me go back and look at the fraction. Probably should have done that before I moved on. I had this fraction 1/2, and if my memory recalls, it was to the 2nd power, and that meant, I'm not going to go through the whole what's the base, what's the exponent, since we did this once. It meant take the base, the half, multiply it against itself. The exponent, the 2 here, observes the parenthesis and respects it. It modifies everything inside the parenthesis. If I were to write this differently, if I were to write this like that, then as far as the exponent is concerned, the base is just 1. So if I were to now work this out, and again, this is a very big deal here because it's an easy mistake to make. All I would have to write is multiply the base. In this case, now it's just a 1 against itself twice. 1 times 1. The denominator is not going to get modified, because now the exponent doesn't observe it. It's no longer part of the base. 1 times 1 is 1. That's back to being a half. Here, if we remember, that was 1/4. Very distinct numbers. Very distinct. So be very, very careful. The exponent will respect the parenthesis, and it will modify anything inside the parenthesis. But if there is no parenthesis, the exponent only modifies what it is directly attached to. In that case, that's the 1 and not the denominator 2. If this exponent was for some reason on the bottom, then it would only modify the denominator and not the numerator. If you have a parenthesis around the entire fraction, then the exponent modifies the entire fraction. Alright? Now let's take a look at what this looks like if I have a problem that involves multiple exponential forms. Let's say I have 2 to the 3rd power plus 3 to the 2nd power. Okay, that's not so bad. And I I'm keeping it as simple as I can. Now, how would I write the 2 to the third power out of its exponential form? What would that look like? Can someone tell me? We have an exponent of 3. It's modifying the base 2. It's telling the base 2 to multiply against itself 3 times. 2 times 2 times 2 times 2. Then we have a plus. We'll just write that plus. What about this one? How would we write this outside of its exponential form? Exponent 2 modifies the base 3, tells the base multiply against yourself twice. And now we can just crunch our numbers. 2 times 2 times 2 is 8. 3 times 3 is 9. And that is just 17. So if you did have a problem like that, where you simply needed to crunch out an addition of 2 exponential forms, that's how you would handle it. Let's look at multiplication. Why not? It really works out the same way. Let's say now I have, let's say 4 to the second power, and I am multiplying it against a negative 2 to the third power. So, what would that look like? How can I represent this outside of its exponential form? Exponent 2, base 4, multiply the base against itself twice. And then times, and I'm going to put a parenthesis around this because we'll need to work this out first. And here we have the base negative 2, exponent 3. I need to multiply the negative 2 against itself 3 times. And again, that's not so bad. 4 times 4, that's 8. Negative 2 times negative 2, that's positive 4. And positive 4 times negative 2 is a negative 8, so times a negative 8. And this should be fairly simple. Can someone tell me what is 8 times a negative 8? If you said negative 64, you're absolutely correct. That's all it is. Take each exponential form one at a time, break it down, work it out, then deal with the other one if there's more than one, and only then do whatever the operation is. So I broke this down, broke that down, figured out what's 4 times 4, figured out what's negative 2 times negative 2 times negative 2, and then I multiplied the two together. That's it. That wasn't so bad. Now let's take a look at a few exceptions to the rule. And these aren't really exceptions to the rule, more like strange cases. So the first one I want to show you is the power of 1. And this one is probably the simplest. It's not really an exception, not even really much of a weird case. So anything to the power of 1 is itself. We don't usually write this, but if I write the number 5, just a plain old 5, there's just one of these, right? It's just a 5. I can easily write this as 5 to the power of 1. Because remember, what does the exponent tell you? It tells you multiply the base against itself this number of times. Well, the exponent is 1, so multiply yourself against nothing. You're just going to be yourself. So the exponent 1 tells us absolutely nothing. It's just the number itself. Every single integer and rational number, when taken to the first power, is just itself. it might as well not exist. It's kind of like multiplying against 1 or adding 0, but multiplying by 1 I think is a better analogy. It might as well not be there, so we never really write it. So that's that. I'm not going to talk much more about that. But in some cases, that is important to know and important to remember that any number or variable, so I can write x as x to the first power, for example. And in some cases, this could be useful. It will be useful to know that there is an exponent there. An exponent of 1, so it's not nothing, and it's not 0. We're going to talk about 0 in just a second. There is an exponent there. It just doesn't do anything for us in normal math, so we don't usually write it. But there is an exponent of 1. It just tells them the base, multiply yourself against nothing. So that's why we don't really write it. It's kind of like why we don't write 1x. We just write x because 1 times x is x itself. But sometimes it's useful to know that that 1 is in front there. Second interesting case, taking anything to the 0 power. So I'm going to use the 5 here. I'm going to use the x here. I'm going to use a negative 2 here. And I'm going to use the 1/2. Pretty much most of our examples, I guess. And I'm going to take them all up to 0 power. Zero power is a little interesting. And all 0 power says that if you are taken to the power of 0, so if your exponent is 0, regardless of what your base is, you always end up being 1. Simple? Yes. 0 power or exponent of 0, regardless of what the base is, you are 1. Unless, exception time, unless you're 0. If you are 0 taken to 0 power, you're still 0. I'm sorry, 0, you don't get to be anything but 0. So zeros don't magically turn into 1s. No. Everything else magically turns into 1, but 0 stays 0. So 0 is the exception here. 0 to the 0 power is still 0, but anything else taken to the 0 power is just 1. So that's not so bad, just something you got to remember. And now let's talk about the last bit of this lesson, and then we're going to finish this. I'm actually combining sections 4.1 and 4.2 here. That's why it seems like it's a little bit long, because we are technically doing 2 sections here. This is that second section. Now the second thing I want to talk about is negative exponents. Let's say I have, let's take our 5, let's take our x, let's take our negative 2, and let's take our 1/2. And let's give them all a very, very simple negative exponent. Let's say negative 2. Negative exponents do a single modification to what normal exponents do normally. There's one modification that they do. They tell you to take the inverse of the number, or in layman's terms or simple terms, flip it. And this is what it looks like. And it is very simple, and you're going to be like, oh, this is really it? That's not bad at all. So let me show you what that looks like. I'm looking for a different color here, and this will have to do. Okay. That's it. Negative exponents tell you, take whatever base you have and take its inverse. Flip it. The exponent in the process turns positive. Was negative, became positive, and as you flipped, you're done. Here is 1 over x. The exponent sticks around, but now it's positive. Here, similar thing happens. 1 over negative 2. The parentheses stay, the parentheses don't go anywhere. And the exponent also doesn't go anywhere. So that's that. And the last one, I'm kind of running out of space here, so I'll just write it beneath. Right here. So what's the inverse of a half? If I flip a half, it's 2 over 1, or just 2. I can write the over 1 here, but I'm honestly hoping that that is not going to be necessary. You guys know that 2 over 1 is 2. And of course, the exponent is still there. So whenever you have a fraction, just flip the fraction. And as easy as that, as you flip it, you turn the exponent positive. Let's practice a few of these, and then we are going to be done. I'm going to call it a day, because it is almost 6:30 here. And this is the time when I usually start making mistakes. Alright, anyway, so let's just do a few easy practice problems, and then we are done. So let's say I have 4 to the negative first power. Can someone tell me what I would do there? If you said, first of all, flip it, you would be correct. The inverse of 4 is 1 over 4. And the power of 1 remains. Does that power of 1 do anything for us? Or can I just ignore it? If you said just ignore it, because anything taken to the first power is the number itself, then you were absolutely correct. That's that. Not bad at all. Okay. Let's look at 26.5 negative, all taken to the 0 power. Can someone tell me what that is? Just 1. I picked that on purpose. You're probably getting scared. Oh my god, we have to do some crazy multiplication. Nope. Taken to the 0 power is just 1. Easy as that. Alright, let's take a look at another example here. And yes, keep writing these down. You're awesome like that. Let's take a look at another negative exponent. How about we do 3 over 4 and all taken to the negative 3rd power. So what will be my first step? Flip first. The inverse of 3 over 4 is 4 over 3. Now the exponent. Now the exponent's still up here. Because we have that parenthesis, it's going to observe the entire parenthesis, so it's going to apply to everything inside. So the exponent actually doesn't travel down with anything because it's being barred by the parenthesis. And then of course I can break this up and write this as 4 over 3 times 4 over 3 times 4 over 3, which you can figure out and write down what that is. Can someone tell me what is that particular fraction equal to? If you said 64/27, you'll be correct. Or that somehow doesn't sound, no, yeah, that's about right. It's getting late. Probably should stop soon. Okay, now what if I have this interesting case? What if I have, let's see here. What if I have 1/2 all taken to the negative first power keep doing that, plus 2 taken to the 0 power plus 3 taken to the negative second power. What's that going to look like? Negative exponent, I have to flip, and since the exponent itself is 1, it's gone. I don't have to write it. And 1/2, the inverse of that is 2/1, or just 2. 2 to the 2 to the 0 power is just 1. 3 to the negative 2 power, I got to flip first, and the exponent ends up down here. And 2 plus 1 is 3, so this is simply 3 plus 3 to the second power is 3 times 3, and that's 1/9. And then you can combine these. We're not going to get into that. This was just a fun problem. If you can do this, you're golden with this section. So any questions with this section? I'm going to finish this up because it is getting quite late. Thank you.